Okay, so today we are going to be talking about limits. Limits is when you are finding the value of a function as it approaches a given x value. So why do we need to know this? So the reason why we need to know this is we need to be able to figure out how fast something is going at a particular time. And it's really easy when we have, say, a linear relationship. So say I have written down positions of an object over time. Let's call this meters and let's call this seconds. And I see at 1 second my object is at 0 meters. And after 1 second later, it's now at 2 meters. And another second later, it's at 4 meters. So we can see that my object here is moving at a constant rate. And I can find what that rate is by finding the slope, or gradient. So if I find my slope, it's up 2 over 1, I can see that my object is moving 2 meters every second. So I can take my speed and say that my object is moving 2 meters every second. And we write that as 2 meters per second. We write second to the negative 1. Okay, so that's its speed. And so we get that from using the slope or the gradient. So the speed is the slope of the line. And in IB, that's called the gradient. But what if my object is moving more like this? It starts out slow and then it gets faster and it slows down again. How fast is it going? Well, I could give an average speed from here to here. I could figure out what the average was. But what if I want to know exactly how fast it's going at, say, 1, 2, 3, 4 seconds? Right here. I want to know right here, how fast is my object moving? Well, its speed changes over time. Okay, so it's slower down here and it's faster up here. But what is the speed at exactly 4 seconds? So this is what we use calculus for. We use it to help us find the actual slope of a curve. So, of course, slope is rise over run. So I'm going to need a rise and a run. In order to have a rise and a run, I need 2 points. But I want to know exactly what it is at 1 point. So how can I have 2 points be 1 point at the same time? Well, we can't really. So what we want to do is we want to get incredibly close to this. So I could say pick 2 dots, say here and here, and there's a line, and I could join those together, and I could say, well, I've got a line there. I could find the slope of that line. Would that be the speed right at that point? Well, what if I closed in a little bit? What if I put my point here and here? Is that going to change it? If I draw that line, that changes it a little bit. Well, what if I get a little bit closer? If I take 2 points that are even closer and I join those together, well, as you can see, that's given me a slightly different slope. So we use calculus and we use the idea of limits to get closer and closer and closer to a single point on a graph. And these are called tangent lines. I want a line that just touches my graph exactly at the location, in this case 4 seconds, and I want to know what is the slope of that tangent line. And that would tell me the instantaneous speed. How fast am I going at 4 seconds? So that's what we're going to use calculus. It's going to help us figure out what exactly is the speed at a point on a curve. Okay, it's really easy if I have a straight line, but not when I have a curve. Okay, so speed here, speed is the slope of the tangent line. It's the slope of a line tangent at a given point. So before we figure out how to calculate that directly, we need to come to the idea and be able to calculate limits. So I want to know what's happening as I get closer and closer and closer to this value, x equals 4. So that's what we're going to be looking at today. Okay, so we want to know what is happening as we get closer and closer to a point. Okay? So what we're going to be doing is we are going to be finding the value of a function close to a given x value. So basically we want to find the value of this function as it gets really close to 4, but not exactly at 4, but really close to it. And we call that the limit. What is the value? And the value would be the y coordinate. What is the value of this function as it gets really close to 4? And I can ask for it from below 4, and I can get it from above 4. I can ask for that limit. And then I would be able to calculate the instantaneous speed at this point. So that's what we're trying to do. So I'm going to write this out. When we want to find the value of a function close to a given x value, we call it a limit. Okay, another way of saying it is we say f of x, that's our function, converges to a value, we're going to give it a letter, a value a, as x approaches lowercase a. So I'm going to write this out symbolically. So how do we write this symbolically? I want to know the limit, what happens as x approaches a value. So for example here, what happens as x approaches 4? So as x approaches 4, I want to know what happens to my function. What happens to my graph? What value do I get? So that would be what y value do I get as I get closer and closer to a particular value. Okay, so this is how we write limit problems. Just like this. So we're going to start with some baby steps, and we are going to do an example, which then you're going to be able to use in class tomorrow. Okay, so we're going to take baby steps with limits. But basically, limits help us to find the instantaneous speed of an object when it's not on a linear, it doesn't have linear speed, when it's not going at constant speed, but rather the speed is changing. All right, so here's our example. So I want to know what happens to the function f of x, 5x plus x squared over x, as x approaches 0. What happens? Okay, so I want to know what happens as x gets really, really close to 0. Well, let's see what happens at 0. So first of all, this is how we write it. The limit as x approaches 0 of, and then we write the function. This is how I write the problem. Here's my function. I want to know what happens when x gets close to 0. So let's first of all just go ahead and plug in 0. If I can plug in 0 and get a value, then I'm good. So let's see what happens. Okay, so I'm going to change x to 0. Change x to 0. So I'm going to have 5 times 0 plus 0 squared over 0. And I get 0 divided by 0. All right, so that's a problem. I'm not allowed to divide by 0. So apparently my function is undefined when x equals 0. Okay, so this is undefined. But that doesn't mean that it's not approaching a number. This could be coming really close to something, but just never reaching it. So what is it getting really, really close to? So to figure that out, what we're going to do is we're going to simplify this fraction. So that's why I had you doing that work in math space, simplifying algebraic functions, because it will help us figure out what is happening to this function as we get really close to 0. Okay, so we are going to factor and simplify so that we can find the limit as x approaches 0. Okay, so we are going to factor and simplify. Factor and simplify. So we've got 5x plus x squared over x. So notice in my numerator, they both have an x in common, so I'm going to factor out my x. Let me check that. X times 5 is 5x. X times x is x squared. Now, notice it's factored. I have something, x times the parentheses on top, and then just an x on the bottom. So now I can reduce this. X divided by x is just equal to 1, so I'm left with 5 plus x. Now, substitute in, now change x to 0. Okay, so now what happens when x is 0? So 5 plus 0, I get 5. So that means that this function, as x gets really close to 0, it's going to be approaching the number 5. So my limit as x approaches 0 of 5x plus x squared over x, what does it get really close to? It approaches the number 5. And there it is. That's my answer. And that's what we're going to be practicing in class tomorrow. Okay? Pretty simple. That's it.